Hi, folks. All right. You all here for some extra work on partial fractions? Or did you have other questions? Okay. Is there a specific problem you'd like to work on, or you want me to pull some of the homework questions and we can kind of work through those?
Can we, yeah, I would like to do some of the homework questions, and then as well as I have some questions on the quiz that was just turned in, quiz 15.
For sure. We can start with the quizzes. Does that work for you?
Yeah.
All right. Which quiz question would you like to go over?
Can we start with quiz 15, number 2?
Number 2. Okay. Let me go ahead and share my screen. And we will start with number 2. Okay, so quiz 15, number 2, looks like negative x squared plus 2x plus 4 divided by x cubed minus 4x squared plus 4x. Okay. So I would say that the first thing to do anytime you're looking at a partial fraction question is to go ahead and factor the denominator. So if the denominator is not already factored, then we want to go ahead and factor it. Okay. So maybe we can say like step 1 is factor the denominator. And so when we look at the denominator, we have x cubed minus 4x squared plus 4x. Even though this is a cubic, we might notice that every single term has an x, and so therefore I can factor out an x. And then I get x squared minus 4x plus 4. Does that first step make sense?
Yes.
So then we also need to see, can we factor the quadratic? And so the x squared minus 4x plus 4, we can actually factor that more. So we get x times x minus 2 times x minus 2. Okay. So that's our first step where we factored the denominator. Any questions so far?
No, it looks good.
Then I would say we set up our partial fractions. And so that's where we kind of go back into the notes because we have our 3 denominators, right? We have an x, we have an x minus 2, and an x minus 2. So what we're saying is that this negative x squared plus 2x plus 4 over x times x minus 2 times x minus 2 came from 3 fractions added together. Now, I know that it's 3 because I have one denominator, I have another denominator, and I have a third denominator. Okay. So one denominator is going to be x plus the next denominator is going to be x minus 2, okay, plus the last denominator is going to be a little bit different because we have right here repeated factors. So we have like the x minus 2 once in the blue, and we have it again in the purple. So the last denominator is actually going to be x minus 2 squared. Does that part make sense so far?
Yes.
Okay. So then, do you know how we find the numerators? Like how we know what we put on top in terms of the setup?
Yeah, I know that like it follows like A and then A sub 1 and then A sub 2, but we usually put like A, B, and C.
Perfect, perfect. So one thing to notice here is like x is linear, right? This first denominator is linear. So if this is linear, the numerator of it has to be a constant. So just a number, no x on the top, because otherwise they would cancel out. And then over here with the blue one, the blue denominator, we have x minus 2. That's also linear, so I need a different constant on top of that one. Now I'd say this last one is probably the tricky one because you have the purple one, but it's also squared, okay? But when we think about what goes on the top, we have to think, what's 1 degree less than just the x minus 2? Like we sort of ignore the squared part when we think about what goes on top. So the bottom is that purple x minus 2, which is linear. And so on the top, we have another constant. Yeah.
If it was cubed, would it be different?
If you had x minus 2 cubed, then you would just have a linear one. So it all goes back to like, what is this thing? Not the repetition, but what is the thing that is being repeated?
Okay.
So if the x was squared, like inside of the factor, then that's when we would put two different variables or constant?
Exactly. So if I had like x squared plus 1 squared, like what's that thing on the inside? Well, that's a quadratic, so I need a linear on top.
Okay.
Okay. If I had x plus 5 to the 10th power on the bottom, it's still just thinking about what is x plus 5, and x plus 5 is linear, so I would put a constant on top. But if I change that to be x squared plus 5 to the 10th, x squared plus 5 is quadratic, so the top becomes linear.
I don't know if this question makes sense, but what on the inside, is it always going to be constant? So like x cubed plus 5, and then the other one like x cubed plus 6, and then it just goes like that. So like, is it going to stay constant, or are we going to have like x cubed or and then x to the 4th? Does that make sense?
Are you talking about like this inside factor?
Yes.
Yeah. Okay. So we're mostly going to see cases that are linear or quadratic. Those are the two main situations we need to know about, a linear versus a quadratic. So we won't really see like x cubed minus 2 on the inside. We won't see that.
Okay, thank you.
Okay. So then we factor the denominator, we set up the partial fractions. So on the exam, when I say set up, I need you to factor the denominator and just tell me like what letters are on the top. Do you have a constant on the top or do you have a linear on the top? Those will be sort of the two cases. Now, if you're gonna actually work through the entire problem, then we need to find a common denominator. So the least common denominator for both sides. And so we have our negative x squared plus 2x plus 4 over x times x minus 2 times x minus 2 equals. So if I just focus on this a over x, what do I need to multiply the x by to get the denominator to be the same as the other side? Right, so that was our original fraction. And I noticed that has a green one on the bottom. Like it has this x, that's green. But what it's missing is the blue factor. And it's also missing the purple factor. So I have to make sure I multiply the first fraction by the blue factor and the purple factor. So that way the entire denominator looks like the denominator on the other side. And I did that for A, and now I have to do that for the second fraction. I have to do that for the third fraction. So when I look at the second fraction, I notice that right now it has B, and on the bottom it has the blue x minus 2. So to make it the same as the other side, I'm going to need the green x and the purple x minus 2. So then the last fraction, it has x minus 2, but it actually has both the blue and the purple one already. So there's the purple one, but then I squared it, so that actually takes care of the blue one. Then the only thing I need to multiply the last fraction by is the x, so that I get blue, purple, and green in the denominator. Okay. Any questions about getting this lowest common denominator? Okay. What do we do after we find that least common denominator? Well, the good thing about that common denominator is we get to say, goodbye. We don't even need you. Now we can only work with the numerator, okay? So we get rid of the denominators and only work with the numerators. Okay, so it's a lot of writing, but I'm going to rewrite just the top line. Okay, so we get negative x squared plus 2x plus 4 equals a times x minus 2 times x minus 2 plus b times x minus 2 plus c. Now, from here, we have options, right? We can try sort of that shortcut method, or we can set up a system of equations. Do people in the session have a preference of what they would want to see right now?
Can we see this shortcut, please?
Mm-hmm. Okay. All right. So we can solve for A, B, and C by being clever about how we choose our numbers, right? So maybe one good number to choose would be 2. And I'm choosing 2 because that's going to make the blue and the purple factors equal 0, which is good because some things will go away, okay? And so let's try that one. Now you got to plug in 2 on both sides of the equation. That's why I write the whole equation now. So I get negative 2 squared plus 2 times 2 plus 4 equals A times 0 times 0 plus B times 2 times 0 plus C times 2. Does that make sense where I got all those numbers from? Okay. Now the good news is when we choose the shortcut, like Christina suggested, a lot of things tend to go away. So this whole term with A is going to go to 0. And yeah, it's B times 2, but it's also B times 2 times 0. So this second term also goes to 0. And so we end up with, let's be careful about our signs on the left-hand side, negative 4 plus 4 plus 4 equals 2C. And so I end up with 4 equals 2C, or C equals 2. Okay. Now we can repeat this process by choosing another number. Let's let x equals 0. Okay. And I'm choosing 0 because that green factor is just an x. And so when I plug in 0 for the green factor, that one makes that 0. And so now I'm going to plug in 0 in the same equation I plugged in 2. So I'm going to get negative 0 squared plus 2 times 0 plus 4 equals A times negative 2 times negative 2 plus B times 0 plus B times 0. Okay. And these go to 0, which is good. And this simplifies to giving us 4 on the left-hand side equals negative 2 times negative 2 is a positive 4A. So then A equals 1. Yeah? So by this shortcut, we were able to find A and C. That means the only thing left that we need to find is we need to find B. Okay? Now, when you have the repeated factors, let's actually make a note for ourselves that the shortcut won't work totally in this case. Okay, so anytime you have a repeated factor, like a factor that shows up more than one time in the denominator, you can use your shortcut to get started, solve for some of the letters, but you won't be able to solve for all of the letters with only the shortcut, okay? But this is where somebody in class was like, well, let's just pick another letter to plug, another number to plug in, right? Another nice number to plug in for X. Because what we can do is plug in our number for C and our number for A, okay? So let's say, I'm gonna say let x equal 1. And there's no real reason for this other than 1 is a nice number to do mental math with. That's just it. So I'm going to plug in 1 into the same equation I plugged in 2 and the same equation I plugged in 0. So let's see, negative 1 squared plus 2 times 1 plus 4. That's the left-hand side. Equals a times 1 minus 2 is negative 1 times 1 minus 2 is negative 1 plus b times 1 times negative 1 plus c times 1. And then those special substitutions we can make, everywhere I see a c, I can put a 2. And everywhere I see an a, which is right here, I can plug in 1. Okay, so there's like an extra substitution I can make. So let's clean up the left-hand side. We get negative 1 plus 2, which is 1, plus 4 is 5. Now, this becomes 1 times 1 plus negative b plus 2 times 1. So that gives me 5 equals 1 minus b plus 2. Or 5 equals 3 minus b. So I'm going to add the b to the left-hand side, and I'm going to subtract the 5 to the right-hand side, and I'll get b equals 3 minus 5 is negative 2. Okay. So I found my b value, I found my a and my c, but let's just make a note that this one is because we can't find all letters using the shortcut, we just pick a nice number and substitute. Okay, so that's the part where if you have a repeated factor, because the shortcut breaks down, we have to sort of be a little bit more creative and use nice numbers along with numbers we already found to find the last variable. Once you've got all that, you plug in 1 for A, negative 2 for B, 2 for C into this original equation, or not original, but into your setup, and then that's your final answer. Okay. Let me zoom in a little bit so you could kind of see it all on one page. Does that help clarify questions? Or am I still saying the same stuff and it still doesn't make sense?
Yeah, it makes a little more sense now. I had a question for the when it's like already simplified, the original type, I don't remember what it's called.
Like when it's already factored?
Mm-hmm.
Like number 3?
On the quiz?
Yeah. Or what do you mean by already simplified?
Yeah, like number 1 on quiz 15. Because, so how do you like reduce your answer? Like, is that possible? Because I was trying to do the WebAssign and it said to like simplify my final answer.
Okay, which question from WebAssign are you talking about? Maybe let's just do it.
Number 2.
Okay. All right. So number 2 from WebAssign. Do you want to read me your question?
Yeah, I have 5x over x squared minus 4.
Okay, cool. They changed the numbers a little bit from problem to problem, but we'll just use your numbers. Make your life a little easier. Okay. So this was your question, right? 5x equals x squared minus 4.
Yeah.
So when you start to factor the denominator, you get x plus 2 and x minus 2, yeah?
Mm-hmm.
And then this is our very first case. So this is where there's no repetition, everything is linear. So we just have x plus 2 on the bottom of one and x minus 2 on the bottom of the other. And it doesn't matter which one you put first or second. Okay, so I just took this one and I put it here. And I took this one and I put it here. So the numerators of this, because both of my denominators are linear, 1 degree less than that is a constant. So I just have an a on top of the first one and a b on top of the second one.
Mm-hmm.
So now let's think about how we can make those denominators the same. So what do you want to multiply the first fraction by?
X minus 2.
Perfect. Right? If we're thinking about the colors, we have a green. We already had the green. So to make it look like the other side, we also need a blue factor. And if we do the same thing for the other fraction, we'll get b. It already had the blue one. So now we need to multiply by the green one. Right? So everything is blue and green on the bottom, which is excellent because now we can say, go away. I only want to focus on the numerators now. So we get 5x equals a times x minus 2 plus b times x plus 2. Now, I think I chose this one because you should get a fractional value for your a and b. So if you got a fraction, let's just talk about how WebAssign wants you to type it in. So we can use our shortcut here. We can let x equal 2. And then separately, we can let x equal negative 2. So if I plug in 2 into my equation, I'll get 10 equals a times 0 plus b times 4. And so that gives me 10 equals 4b, or b equals 10 fourths. So since I can reduce that, I'm going to reduce it to 5 halves. And if I do the same thing for x equals negative 2, I get negative 10 equals a times negative 4 plus b times 0. So I get negative 10 equals negative 4a, or a equals 10 fourths or 5 halves. So when you put that back into your answer, our setup was a over x plus 2 plus b over x minus 2. So when we plug our a and our b in, one way you could write it is 5 halves over x plus 2 plus 5 halves over x minus 2. But we generally don't like to have a fraction within a fraction. So what we do is we say 5 over 2 times x plus 2 plus 5 over 2 times x minus 2. So that's what WebAssign is probably looking for when they say like fully simplify.
Okay.
I know, it's one of those dumb things where if you wrote this on a test, totally fine for me. I don't care. I actually love that you knew to keep it as 5 halves. WebAssign wants you to take it one step further and say, let's just write it as a regular fraction rather than a complex fraction. That's all.
Okay.
Okay.
Okay, because I accidentally subtracted 4 from sides instead of divided. So I had like 6 over both of them. And then I thought it was saying to like make it 3 over 1 or something.
No, yeah, that's what it was. That's a good, yeah, I could see that, especially if you did this one first. There's like a negative sign in front. So normally when we see that negative sign, we're just like, yay, we'll just add it to the other side. Cool. Any other homework questions or quiz questions that folks want to see? Feel free to ask. This is the time for you. I'm happy to do any or all of these questions.
Did you go by any chance over number 4 on the quiz? I wasn't here for the first half, so I'm not sure if you went over number 4.
No, we kind of did it super quick in office hours this morning, but we didn't do a very good job. I'm happy to go over that one again.
Oh, okay, thank you. I appreciate it.
All right, so this is okay, so number 4 from quiz 15. Whew, this is a long one, right? All right, so.
Yeah, that's I was like, I need to get a refresher on that.
X to the 4th plus x cubed plus x squared plus minus x plus 1 all over x times okay. So I know on the quiz it says x squared plus 1 squared, but I'm going to write it out as x squared plus 1 times x squared plus 1. Okay, so what we're going to do is, because we have 3 factors on the bottom, x, x squared plus 1, and another x squared plus 1, we're going to need 3 fractions. So the first one will have a denominator of x. The second one will have a denominator of x squared plus 1. Okay. Now this actually is very similar to question number 2 on the quiz, where we have a repeated factor. These two are repeated. And so even though it's a repetition, we need to account for that. And we do that by saying, oh, well, maybe they happen together, x squared plus 1 squared. And so that will sort of take care of the last denominator. Okay? So then to fill in the numerators, we need to think about the degree of the highlighted factor. So the green x has a degree of 1. It's linear. But 1 degree less than that is a constant, so I just need an A on the top. If I look at the blue factor, though, that's a second degree. So 1 less than the second degree is a first degree, which means I have the linear numerator, or bx plus c. Okay. Now, not the whole denominator of the third one, but what is the degree of the highlighted part for the third fraction?
Would it be D? Oh, I think someone put it in the chat, dx plus e.
Yeah, that's exactly right. So the purple part itself, just the purple part. So ignore that little power of 2 outside of the purple, but the purple part is quadratic. So I get to do exactly what I did for the blue one, but just the next letters that come up, dx plus e. Okay. So whatever the degree of the bottom is, the degree of the top will be 1 less than that. So
And that's represented by the bx, right?
Yeah. It's
okay.
We're writing mx plus b, but we just need to use different letters because it could represent different numbers.
Oh, okay. Thank you.
Okay.
So it's always either linear or quadratic?
Yeah, for our cases, yes. Because if we had a cubic and we couldn't factor it, then we would have a quadratic on the top. That happens sometimes. So sometimes you'll see like a cubic on the bottom, and then you would need like an ax squared plus bx plus c on the top. That's quadratic, which is 1 degree less.
Okay, thank you.
So yeah, the pattern still holds. We're not going to take it that far, but that pattern does hold. Okay, so now we need to create common denominators on both sides. So I noticed that I have the green and the blue and the purple on the left-hand side, which means that every single fraction on the right-hand side needs to have the green, the blue, and the purple in that fraction. So to make the first fraction, it already has the green one. So what do I need? I need the blue factor and the purple factor. And if I have that on the bottom, I also need that on the top. So blue and purple. Okay, so that first fraction matches the other side. Now, let's think about what that second fraction means. Well, it has the blue one. So we need the green x, and we need the purple x squared plus 1. So green x and purple x squared plus 1. Okay. Now my second fraction matches the denominator of the first fraction, which matches the denominator on the left-hand side, or our original problem. To make the last fraction match, let's see what it already has. Because as a general rule of thumb, we don't want to do anything more than we need to. So I have the x squared plus 1 of them. But I secretly also have the blue one in there because it's x squared plus 1 times x squared plus 1. So this blue one was sort of hidden by that squared power. So the only thing I need to multiply the last fraction by is we just need an x. Because it has the blue and the green, or the blue and the purple, the only thing we need is the green part. Does that make sense?
Yeah. So it can equal all the other denominators, right? Okay.
So I have x, x, and x. And now all three denominators have have green, blue, and purple. And so once I have all three denominators on the right-hand side equal to all three denominators on the left-hand side, I can get rid of the denominators and only work with the numerator. Okay? So let's write out the equation that we have when we look at just the numerators. Okay, so whoops. So numerators. I have x to the fourth plus x cubed plus x squared minus x plus 1 equals a times x squared plus 1 times x squared plus 1 plus bx plus c times x squared plus 1 plus dx plus e times x. You will not have to do anything this nasty on the test, I promise. Okay, so I don't want you to look at this question and be like, "Whoa, how am I going to get this for the test?"
That's good to hear.
But I think it's good to kind of see that like this same process works. Okay.
Yeah.
So attack this systematically. What I'm going to do first is I'm going to FOIL those out. Okay. And then I'm going to multiply those out. And I'll do those. So these three things in the brackets are going to happen in the first line. So a times, let's see, x squared times x squared is x to the fourth, plus outers is x squared, inners is x squared, so that gives me 2x squared. And then the last term, 1 times 1 plus 1. Okay. Plus bx plus c times x cubed plus x plus dx squared plus ex. Okay, so far so good?
Yeah.
Now let's distribute that a. We're going to FOIL this part, and that last part is already good to go. So ax to the fourth plus 2ax squared plus a plus bx to the fourth plus bx squared plus cx cubed plus cx plus dx squared plus ex. Whew. Okay, so we've got now the fully expanded right-hand numerator, and we've set it equal to the left-hand numerator. And so anytime we have the repeated factors, and especially if we have the quadratic factors, it's probably better to set up a system of equations rather than pick some nice numbers. Okay. So what I'm going to do is I'm going to write out the whole equation now, like the whole right hand and left hand numerators. I'm going to put ones in front of all of those x's. So if it's x to the fourth, I'm going to write 1x to the fourth plus 1x cubed, like that, okay? So we get 1x to the fourth plus 1x cubed plus 1x squared minus 1x plus 1. That's the left-hand side. Equals ax to the fourth plus 2ax squared plus a plus bx to the fourth plus bx squared plus cx cubed plus cx plus dx squared plus dx. Okay. And now, again, I'm going to be really systematic about how I approach this. So I'm going to start with the highest power, and I'm going to collect the coefficients, and then those I will write in one equation. So with the x to the fourth, I have a 1 equals a plus b. And there's no other terms that have an x to the fourth. So I can say 1 equals a plus b. Does that part make sense?
Yeah.
Okay. So I'm going to keep doing the same thing, but for every single letter. So, or every single sort of like term. So x cubed, there's one of them on the left-hand side. So 1 is going to equal c. Well, that's nice. 1 equals c. Okay, let's keep going. 1x squared. Now I have to look for all the x squared terms on the right-hand side. 2a plus b plus d. So 1 equals 2a plus b plus d. All right, let's take a look at all of the x's. -1 equals cx, or c, plus e. Okay, so this is all the blue ones. This is all the green ones. This is the orange ones. This is the yellow ones. And we have one last one to go. Make it a full rainbow. We got +1 equals a, oh, that's it. That's the only other thing we have. So we have 1 equals a, and that's our last equation, okay? And so what we have here is we have 5 equations and 5 variables, but they were actually kind of nice to us because they gave us some of the letters already. So for example, I know that a equals 1. Well, if I know a equals 1, what's a nice number to find next? Or what's a nice letter to find next?
Sorry, can you repeat that again? My internet cut out.
Sure. So if we have a equals 1, what's a good letter that we could find next?
One equals a plus b.
Good, good, exactly. I would take this A, I would plug it into here, and I would get 1 equals 1 plus B. So what does that mean B equals? Just 0. So it's okay for something to equal 0. We just have to make sure that all the work we've done up until that point was accurate, okay? So we have A, we have B, we have C. Oh, they gave that one to us as well. C equals 1. Can I find D at this point?
Yeah, you could.
Yeah, I could do this, right?
Yeah.
Equals 2 plus 0 plus D, and that makes D equal to negative 1. And then last one, let's find E. We've got negative 1 equals 1 plus E. So E equals negative 2. Okay? So let's take all of this, all of these coefficients, and we're going to plug them back into our setup. So our setup was A over X plus BX plus C over X squared plus 1 plus DX plus E over X squared plus 1 squared. And so everywhere we see an A, we're going to plug in 1, we'll put in B as 0, and so on and so forth. So we'll get 1 over X plus 0x plus 1 over X squared plus 1 plus negative 1x minus 2 over X squared plus 1 squared. And so this would be an okay answer. You've technically found all of your coefficients, you plugged them back in, but what might be nice is like, we know that 0 times x is 0, so we don't really need to write that term, so I could like make this one go away, okay? That's one thing that we tend to do. So we'll get 1 over x plus 1 over x squared plus 1. And then another thing we tend to do is if we can factor out a negative sign, we tend to do that as well. So we notice there's a negative and a negative. So I can factor that negative out and I'll get minus x plus 2 over x squared plus 1 squared. Okay. And so that's how we start and also complete this very, very long problem.
Wait, can you go back to how you factored out that negative sign again for the 1x?
Yeah. Okay, so if I just take the last term, negative 1x minus 2 over x squared plus 1 squared, I could write that as negative parentheses x plus 2. Does that part make sense?
Yeah.
Okay, so then if you want to have, remember we were adding this number, so plus a negative number is the same as subtraction.
Okay.
Like when we write like 3 plus negative 4, we're really saying 3 minus 4.
Oh, okay, I see.
It's the same thing, exactly.
Oh, okay, okay. I was just like a little confused. I was like, what happened there? But thank you.
Of course.
It looks less intimidating now, for sure.
Good, good, I'm glad. I think the key here is don't be afraid to take up space on your paper. So use all the space you need, use a scrap sheet of paper. Sometimes like when I'm working on an exam, I have a scrap sheet of paper where it's okay for me to make mistakes. Like I tell my brain it's okay to make mistakes on that paper. Because sometimes when we're writing something for an exam, we just feel like we need to make that perfect. But
Yeah, that's true.
right? But this kind of
Yeah, that's so true.
messy. So keep it organized, but feel free to write as much as you need to.
All right. Thank you for that.
Of course. Anybody else in the room want to see a problem? We can do web assign problems. We can do quiz problems.
On quiz 15, can we try like question 7?
Question 7,
Yes.
the one with the f of x plus h?
Yes.
Yes, for sure. Okay. So in general, with these questions, we're really looking for that substitution piece, okay? This is kind of like in the lesson we did the other day. We said we're given a function. We have negative x squared plus 3x minus 2. And I think in class we had said, okay, well this really, like when we use function notation, what that really means is you, everywhere you see the x, you literally plug in whatever it is you want to plug in. And so we're used to seeing questions that look maybe something like this, like f of 1, where we plug in a number. And if we wanted to plug in a number, we'd say like negative 1 squared plus 3 times 1 minus 2, right? The only difference here is instead of plugging in x, we're plugging in x plus h. We're not plugging in a number, we're plugging in like a quantity. So f of x plus h means everywhere we see the pink dots before, we need to replace it with the whole expression x plus h. So negative x plus h squared plus 3 times x plus h minus 2. Okay. And even though it didn't look that similar because we have only numbers, this 1 went everywhere the pink dots went. So we could do it with just an x, we could do it with a number, or we can do it with this expression x plus h. Does that part make sense to you?
Yes.
Yeah, okay. And then how about the foiling out part? Is that okay?
Do we distribute, or actually no? We would FOIL before we do
Exactly.
anything with the negative, right?
So we're gonna FOIL this part first. So negative. And if it's helpful, sometimes I recommend to people that they write it out like x plus h times x plus h. Okay. Plus 3 times x plus h minus 2. And then if we want to think about taking this in steps, we can FOIL this. We can distribute that. So we get negative x squared plus xh plus xh is 2xh plus h squared plus 3x plus 3h minus 2. And then your last step, we're just going to take care of that negative sign. Negative x squared minus 2xh minus h squared plus 3x plus 3h minus 2. Okay. So the big skill that we're really looking for here is just the idea of substitution.
Okay. Thank you.
You're welcome. All right, what else would people like to see? Any other like partial fractions or anything else in preparation for the exam?
I had a question about Val's tutoring. So it's gonna be tomorrow at 3.
Yeah, tomorrow from 3 to 5.
Okay.
Can we see maybe an example of a non-linear equation, the systems of a non-linear equations? Like 9.3.
Yeah. Do you mind if I use an old quiz question?
No, I don't mind.
Okay. And the only reason I'm saying that is because some of these questions can get very, like the numbers are just so horrible. So I tried to pick mostly ones that were sort of nice. Okay, so let's maybe take a look at number 6. But let's not do the geometry part, like the graphic part. Let's just solve it algebraically.
All right.
Number 6 from quiz 14. Okay, so for number 6 in quiz 14, we had 3x squared minus y squared equals 12. And then we had x squared plus y squared equals 16. And so if we were just looking at it algebraically, we could think, okay, well, maybe substitution or elimination are kind of our go-to pieces. Now, we already know that I kind of favor elimination, which does not mean that you have to do that, but I think one maybe convincing factor here of doing elimination is you've got a negative y squared and a positive y squared. And so if you add your two equations together, the y's are going to go away, which means that you can get an x value pretty quickly. So if I'm going to add my two equations together, I'll get, let's see, we'll stack them one on top of the other like we normally see them. And then we'll just add them. Right? So for me, this is the beauty of elimination. I add things together and all of a sudden one letter's already gone. And now I can divide both sides by 4. And I know 7 is like not a super nice number, but the point here is that I could have a positive or a negative square root of 7 for my x value. Okay. And then after that, I really just want to find the y values that go with it. So maybe to stay kind of organized, I could say x is a positive square root of 7. And then separately, I could say x equals the negative square root of 7. And I could plug that into my other equation to help me find a y value. So I think I'm going to plug it into this equation, just because the numbers are a little bit smaller. So I get square root of 7 squared plus y squared equals 16. or 7 plus y squared equals 16, or y squared equals 16 minus 7 is 9. And here again, I have to be careful. That means y could be positive 3, or y could be negative 3. And so what that means in terms of our two of our solutions would be root 7 comma 3 and root 7 comma negative 3 are two of the places where the hyperbola and the circle cross. And now if I do the same thing for the x equals negative 7, I'll get negative square root of 7 squared plus y squared equals 16. And I happen to get the same thing because I'm squaring it. It becomes exactly like my other equation. I get y squared equals 9, and again, I get y equals 3, and y equals negative 3. So the two values that pair with negative root 7 are 3 and negative 3. And so those are my 4 intersection points for the hyperbola and the circle.
Okay, I got some doubts cleared. Thank you.
All right, anything else that folks want to see? You guys want to see one more partial fraction problem and then we can call it a day?
Yeah, that sounds good.
Cool. I'm going to take a look at question number 8 from a web assignment. Okay, so number 8 from the homework. So some of the web assigned questions have different numbers. If anybody happens to have their web assigned question pulled up, I'm happy to use your numbers for number 8 if you'd like.
I have x squared plus 6 and then x plus 1 cubed.
Okay. So I think this will be a really good one to practice setting up things, okay? So in this case, I actually have 3 factors on the bottom, but they all happen to be the same. So really, I have something like this. X plus 1 times x plus 1 times x plus 1. And so when I go to do my setup, I'm going to need one of the x plus 1s. That's going to be my first denominator. Then what's going to happen is I'm going to need to say, well, what happens if there were 2 of the same one? So like an x plus 1 and an x plus 1. That's another possible combination. Okay. And the last one is really like, well, what happens if you have x plus 1, x plus 1, and x plus 1? Okay. So if we had maybe like a yellow one, a blue one, and a purple one, maybe the second one would be the yellow and the blue. And maybe the third one would be the yellow, the blue, and the purple. Okay. So when we have repetition, and I don't think I asked you to do any that have to the third, like that get repeated 3 times. But if you do see something repeated 3 times, you need to account for it like, What happens if it happens one time by itself, or a pair of them, or finally the third case of all three at the same time? But each one of those highlighted factors, I think we would agree that every single one of them is linear. So that means on top of the x plus 1, I just have a constant. Okay. Now, when we look at the second fraction, we only need to look at one of them, like the yellow one or the blue one. And by themselves, they are linear. So we only need a constant on the top of this one. And by similar reasoning on the last fraction, all three of those factors in the bottom are linear. So on the top, we just need a constant. The only time you need to do like a ax plus b sort of situation is when you have an irreducible quadratic factor. Not a reducible one, but an irreducible one. One where you try and factor it and it gives you like imaginary number. Okay. So if you can factor it into real numbers, that means there are linear factors, and that means the numerator has to be 1 degree less than that, which is a constant. Okay. So let's write out if we want to match our denominators. What do we need to multiply the first fraction by? Well, it already has the yellow one, so we better have a blue one and a purple one to go with it so that it matches exactly on the other side. But if we do that to the denominator, we also have to do that to the numerator. That's the first fraction. Plus, well, how many do I need to, what do I need to multiply to the second fraction? What am I missing to make it the same as the first two that I already have?
Just the purple?
Just the purple, yeah. Cool. And if I do that on the bottom, I need to do that on the top. Excellent. And what about the last one?
Do we multiply it times 1/1?
Yeah. And the clever / lazy way of saying that would be, you don't have to do anything. It's already fine. Okay. So you're right. Sometimes we just need to multiply by 1, like plain old boring 1. You don't even need to make it creative, like x plus 1 over x plus 1. We just need to call it 1. And now I think it's pretty easy to see that all 4 denominators have a yellow factor, a blue factor, and a purple factor. So away they go. And let's see what's left. Now I'm doing a little bit of pre-thinking here. I know I'm going to set up maybe like a system of equation. So I'm going to write it like 1x squared plus 0x plus 6. And my other numerator is a times x plus 1 times x plus 1 plus b times x plus 1 plus c.
So even if it wasn't cubed and it was just squared on the bottom, we would still put the 0x on the left?
Mm-hmm.
Okay.
Yeah. Yeah, so I'm putting the 0x there so that if I want to solve with a system of equations, I'll know like any of the terms on the right that have an x are going to have to equal 0, like together. So let's go ahead and FOIL this out and distribute that. So a times x squared plus 2x plus 1 plus bx plus b plus c, which is ax squared plus 2ax plus a plus bx plus b plus c. And we have 1x squared plus 0x plus 6. Now, I do want to show us one solving by systems, just in case, okay? So if we wanted to solve by system, we would go ahead and say, what are all the terms that have an x squared? And we're going to pull all their coefficients and make a special x squared equation. So 1 equals a. So 1 equals a is what I got when I collected all of the terms that had an x squared. It also happened to give us our a value right off the bat, and that's pretty nice. Okay. But let's keep going. Let's see what terms have an x. 0 equals 2a plus b. So 0 equals 2a plus b are all the terms that have an x in them. And then last but not least, positive 6 equals a plus b plus c. And all of those are the equation, that's the coefficients from just the numbers in the equation. Okay. Now this one actually sets it up fairly nicely for us because we can see from here that a equals 1, which means 0 is 2 times 1 plus b, or b equals negative 2. Okay, so we have our a value, we use that to find our b value, and then we're going to plug a and b into the last equation to find the c value. 6 equals 1 minus 2 plus c. And let's see, that will give me negative 1, positive 7. Okay. And once you've got your constants, you plug them back in. So we know at the beginning we had a over x plus 1 plus b over x plus 1 squared plus c over x plus 1 cubed, right? That last case was when we had the yellow, the blue, and the purple. And now when we plug in our numbers, we should get 1 over x plus 1 for the first fraction, minus 2 over x plus 1 squared for the second fraction. And it's a minus 2 because my b value was a negative 2, so I just said, like, instead of plus negative 2, I'm going to write it as minus 2. And then plus 7 over the x plus 1 cubed. That should be whoever numbers we used. For number 8, that should be your solution. Okay. I think the 6 is different for some folks and that 1 is different for some folks. So be careful as you're working through your own question. but it should follow a very similar pattern no matter what your numbers are. Okay. All right, folks. Well, I'm so glad that so many of you were able to make it.
Thanks for your help.